Hi guys, greetings of the day. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my channel yet, kindly subscribe. Also click on the bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now let's begin the session number 47, which is based on multi-cylinder application. What is called as multi-cylinder application? Let us have a small introduction about the same. In any machine or mechanical system adopting pneumatic system, single or multi-cylinder may be used. More often, a complex sequence of operations are carried out by a number of cylinders performing a work simultaneously or in a predetermined sequence in proper coordination. Such applications are called multi-cylinder applications. In most of the situations, a job carried out is made up of number of independent and interrelated events. These events are carried out by independent hydraulic and pneumatic elements, especially actuators, and such operations are called multi-cylinder operations. Each cylinder has to be actuated, that is extended or retracted in a particular sequence in a coordinated manner. For example, machining a component requires a clamping the job, machining the job, declamping and loading is carried out by a cylinder followed by machining by another cylinder or actuator such as hydraulic or pneumatic motor, etc. Any multi-cylinder application requires power coordination and sequencing between the events and hence between the actuators. Coordination is prevention of overlapping or under delay between the motions of actuators, and sequencing is carried out the events in the required or predetermined order so that the job is carried out successfully at the shortest possible number of events and time. This necessitates the control of coordinated motion and sequence of events using proper hydraulic and pneumatic elements in a properly designed and analyzed circuit so that the coordinated motion and sequence control can be achieved. In any fluid application, circuit diagrams are drawn using different hydraulic or pneumatic elements. They are then tested with a simulation tool to check whether the each element is general and system as a whole is functioning satisfactorily as per the design of the system and the requirement. But in multi-cylinder application, the circuit alone may not be sufficient to adequately represent the functional sequence of each cylinder or interrelation between the cylinders. The functional sequence and the interrelation between the cylinders can be best represented and understood with the help of a functional diagram, as well as one more type of diagram that is called as control diagram. We will discuss each and everything in detail. Now first understand what is called as functional diagram. Functional diagrams are a graphical representation of functional sequences of different controls such as electrical, mechanical, electronics, pneumatics and hydraulics, as well as a combination of these controls such as it could be electromagnetic or electropneumatic or electromechanical or electrohydraulic, etc. The main objective of functional diagram is to project a clear and distinct sequence of operation of all pneumatic elements used in a pneumatic circuit. The functional diagrams are of two types. One is called as motion or movement diagram. The other one is called as control diagram. Now let us understand more clearly what is called as motion diagram or movement diagram. Motion diagram is a graphical representation of conditions related to working elements or components. Varieties of motion diagrams are used in engineering control system. Motion diagrams can be drawn in a single coordinate system or in two coordinate system. However, two coordinate system gives a better understanding and clarity and hence commonly adopted. Motion diagrams are drawn for two variables of the working elements such as step and time correspondingly. It could be step diagram as well as time diagram, and the concept of the same you can see in the figure on the right hand side. A step is a change in a condition or position of a component. For example, extension of a cylinder is a step, retraction of cylinder is another step, and also if the cylinder remains in the extended position is also a step, and here the cylinder is a component or working element. It has been more conventional to use motion step diagram to represent the motion of pneumatic drive elements. It is conventional to select the x-axis for a step and time and y-axis for motion, speed, position, etc. Now let us understand more clearly about what is called as a step diagram, that is displacement step diagram. In clearly we will understand with respect to the figure. Displacement, that is with respect to a step diagram, represents the operating sequence of a working element such as cylinder, motor, etc. The motion or displacement is recorded in relation to various steps that would occur during a particular operation or process. If control system has several working elements, then separate displacement step diagrams are drawn for each element one below the other. Then the relationship between the elements is shown by the combined displacement step diagram. In displacement or position, that is nothing but the step diagram, the process of operation is divided into number of steps which are expressed in numbers like 0, 1, 2, etc. Positions are indicated as 1, 2, 3 and so on. For example, in an extending and retraction of a cylinder, retraction and extensions are steps and retracted and extended activities are positions which you can observe. Now let us understand the steps. Two steps are involved. Number of steps are those starting from the initial position, different sequences, or steps till the element is brought to its initial position. That is 0 step, no motion, 1 to 2, and retraction. And 2 is equal to 0 indicates the reaching of initial step or position. The line joining the step position in proper sequence is called functional lines, which you can observe the figure. These are drawn in a dark thick lines and they determine the status or position of controlling or controlled element during the sequence of operation of the whole process. Now, what are the recommended procedure for the motion diagrams? Let us understand in detail. The step should be represented on a horizontal linear axis. If possible, the displacement should not be drawn to scale but of equal size for all components. With several components, the distance between the displacements diagram should not be made too small, approximately half of to one step distance. If the condition of the system changes during the motion of the element, that is, by operating a limit switch while the component is in mid position or due to change in the advancing speed, intermediate steps may be introduced. The steps may be numbered as required, and the designation of the condition of the component is optional. The designation of the component must be written on the left hand side of the diagram, for instance, like cylinder 1. Next, we will discuss one more concept that is called as displacement based on the time diagram, similar to the step diagram. And the respective figure is there in the slide at the right side top bottom corner. This is a diagram representing the displacement of a component with respect to time. In contrast to displacement step diagram, the time axis t as drawn horizontally to scale and thus the relationship between individual components is going to be established. So by this, I would like to conclude this session. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan.